Hello, people. Today we'll be looking at a recurrence relation problem. We'll be applying the tree method to solve for the time complexity. Here is the problem we are looking at. This one. Okay. So, based on what you have, we can tell that when the input is Tn over 3, you're going to get Tn over 9 plus T2n over 9 plus n over 3. Okay? This part is the work done, non-recursive. Okay? Work done. This part is recursive. This part is recursive. All right? So now I got n divided by 3 as the work done when the input is Tn over 3. Now, what about when the input is 2n over 3? What will be the work done? Let me firstly look at the recursive cases. So the first recursive case is going to be T2n over 9 plus the next recursive T 4n over 9 over 9 plus 2n over 3. You see that? So you can see the work done at each of the level. This is one of the work done at this level. This is work done at this level. This is work done. That's why you see this 3. The 3 starts from n, which is the work done at the root level. The next, you see n by 3, that's this one. You see 2n by 3, that's this one. And so on and so forth. All right? So that's the idea here. Now, to get the total work done at each level, you add all work at each node of the same level. Okay, so now I'm going to add at this level. Now I'm going to say n over 3 plus 2n over 3. This is going to give me n. Remember, the first one gave me n, right? So that was, we got this from the actual series. Now I have n. Now, if you pass n by 3 as input, again, you will see what the work done will look like, and that's what you get here. Okay, that's what you get here. So what will happen is you would add all this together to see what the result will be. So n by 9 plus 2n by 9 plus 2n by 9 plus 4n by 9. You see that? So what you have there is like 9n by 9. Everything is going to be n. That's why this guy is also n. So at every level, the total work done will always be n. If that's the case, I just need the height of the tree. Because if I know the height of the tree, I'll multiply the height of the tree by n, and I'll get my T of n. T of n is going to be n times the height of the tree. See that? Okay. Now, in a bid for me to determine what the height of the tree is, I will look at my tree structure and see the longer part, because it is not balanced. Let me just clear this guy, clear everything. So this is the tree structure. If you look at it, this part is going to be the longer route. See that? As a result, I will trace that longer route, look at a series, get the pattern, and equate the pattern to 1 at the base case. So the first is n, Second is 2n over 3. Next is 4n over 9. The next is going to be 8n over 27, and so on and so forth. So based on this, I can say that the pattern is n 2 over 3i. See that? So this is going to be the pattern of the input at this longest route. Okay? The pattern of the input at the longest route, not any other route, right? Because that's what I'm considering. So at the base case of this the longest route now, I will equate this to 1. That means I'm going to say n 2 over 3 all I equals to 1. And when that is the case, 2 over 3 all I is equals to n minus 1. That's n reciprocal, right? So I can, from here now, I can take the reciprocal of both sides, because I want to get rid of that negative 1, right? So I can say this is 1 over 2i is equals to 1 over n minus 1. So this will give me 3 over 2 all I equals to n. Now I can take the log of both sides. If I do take the log of both sides, I'm going to have I is equals to log n over log 3 over 2. And when you have something like that, that is like I equals to log n base 3 over 2. See that? So this is the height of the tree. So I already have the height of the tree in terms of n. So what do I need? I'll just say n times, so I'll say t of n is equals to n times log n base 3 over 2. So my t of n now is going to be big O of n log n. Okay. So that's the time complexity. So that's what you're seeing here. All right.